The most expensive city ever built is 2.4 kilometers long. It has no residents, no walls, no roof, no glass. It is a strip of concrete foundation in the Saudi desert. Price tag, $50 billion. That is the entire output of the most ambitious construction project in human history. You are paying for this, not directly, but the steel that never arrived at your construction site, the concrete that became scarce across 3 continents. That was the line. At its peak, this project was consuming 1/5 of all the structural steel available on the global market. Every major building going up anywhere on Earth was competing with a city that did not exist yet. This week, the last major contractors walked away. Hyundai Engineering, Webuild, Eversendai. 3 cancellation notices in 17 days. The tunnel, the dams, the steel, all terminated. Construction suspended since September 2025. The project frozen. So how do you spend $50 billion and build almost nothing? The answer is buried in the engineering. And the engineering was always the story that nobody wanted to tell. January 2021. Crown Prince Mohammed bin Salman stands before the cameras and describes a city unlike anything built before it. 170 kilometers long, 500 meters tall, 200 meters wide, the entire length clad in mirrored glass. No streets, no cars, no carbon emissions. 9 million people living inside a single continuous building, stretching from the Red Sea coast to the mountains of Tabuk. He calls it a civilizational revolution. The engineers in the room hear something different. They hear the most structurally complex object ever conceived by human beings, and they have to figure out how to build it. Start with the most basic problem, the site. The Tabuk Desert sits in northwest Saudi Arabia, 500 kilometers from Riyadh. No roads capable of carrying heavy loads, no rail connections, no nearby ports rated for industrial freight, no water. Workers need somewhere to sleep, eat, and work before a single foundation pile can be driven. Before construction starts, you have to build the city that builds the city. They build it. Worker camps for over 100,000 people, a dedicated airport, haul roads cut through virgin desert, a concrete plant designed and constructed from scratch, carbon capture technology, 20,000 cubic meters of ready-mix output per day. Before a single permanent structure goes up, hundreds of millions of dollars disappear into infrastructure the world will never photograph. Then they start on the foundation, and this is where the numbers stop cooperating. The plan calls for more than 30,000 foundation piles for Phase 1 alone, each pile drilled deep into desert substrate, some reaching 70 meters below grade. 70 meters. That is the height of a 20-story building, driven into the earth before you even begin the actual structure above it. The piling operation for the initial 2.4-kilometer section is, by itself, arguably, the largest foundation project ever attempted in a single construction phase anywhere on Earth. The desert substrate is not uniform. Variable geology forces individual pile designs. Crews adapt specifications pile by pile, drilling blind into material that changes every 10 meters. They use continuous flight auger rigs for the shallower sections, reverse circulation drilling where the geology gets harder. By late 2024, roughly 1,000 piles driven. Out of 30,000 planned, 3% of the foundation for 1.4% of the city. Workers drive the piles. Then the concrete arrives. The plant produces 20,000 cubic meters per day. The full project requires hundreds of millions of cubic meters. At that rate, supplying enough concrete for Phase 1 alone takes years. Scaling up means more plants, more equipment, more water. Water in a desert that has none. In the early stages, water is being trucked to the site by tanker. Not piped, trucked. For a project whose central promise is sustainability. The engineers know this is not a scalable solution. They write reports. The reports go up the chain. The chain ignores them. Now the steel. The design calls for 40 vertical cores, each 500 meters tall, rising along the initial 2.4-kilometer section. Once standing, those cores get connected by 2 million tons of structural steel trusses, the horizontal platforms and main decks that give the line its shape. 2 million tons of steel for 2.4 kilometers. That is more structural steel than the entire London skyline contains above ground. The trusses must be prefabricated at ground level and lifted into position. The nearest heavy fabrication facility capable of working to those tolerances does not exist within 1,000 kilometers of the site. It has to be built. Then comes the thermal expansion problem. Steel expands when it heats. In Tabuk, daytime temperatures reach 55 degrees Celsius. A steel truss 200 meters long expands by roughly 28 millimeters between morning and midday. Multiply that across 170 kilometers of continuous steel structure, without expansion joints engineered specifically for the geometry of a linear building. Not a tower, not a bridge, but something in between. The building tears itself apart from thermal stress before any resident ever moves in. No engineer had designed these joints before. The calculations had to be invented. Every solution generates a new problem. Every new problem adds cost. Then the transit system. The line promises a 20-minute end-to-end journey across all 170 kilometers. That requires speeds above 510 kilometers per hour inside a tunnel. The fastest commercial rail on Earth, China's Shanghai Maglev, tops out at 430 kilometers per hour on dedicated track with decades of refinement. The line needs to beat that, inside a buried tunnel beneath a 500-meter inhabited structure, using propulsion technology that does not exist in prototype form anywhere on Earth. Engineers search for a comparable system. They find nothing. The technology needs to be invented, then tested, then certified, inside a building that also does not yet exist. Every solution generates a new problem. Every new problem adds cost. And then the glass. The entire exterior, 2.1 million square meters of mirrored glass, is not decorative. It is the signature of the project. Crown Prince Mohammed bin Salman's specific instruction to his design team: mirrored, and 500 meters tall, and 200 meters wide. Non-negotiable. Advisors suggest reducing the height to 100 meters to preserve views and cut cost. He is unmoved. 500 meters. Mirrored. Here is what mirrored glass does in a desert. Two 500-meter walls facing each other across a 200-meter canyon concentrate reflected sunlight like a parabolic lens. Engineers model the effect. Reflected intensity on the canyon floor reaches temperatures capable of melting asphalt. Residents walking the ground level in summer face constant heat concentration from both sides. Active cooling would be required at all times. That system draws enormous power from a renewable grid that does not yet exist at anywhere near the required scale. The glass problem is solvable in isolation. Special coatings, dynamic shading systems, automated panels that track the sun and adjust reflectivity. But every solution adds mass, adds power demand, adds maintenance infrastructure, adds cost, and the cost is already doing something remarkable. The original budget, $500 billion. Already, at announcement, the largest infrastructure commitment in history. By spring 2022, internal estimates have quietly revised the number upward, not to $600 billion, not to $800 billion, to $4.5 trillion, the equivalent of Germany's entire annual economic output. The number does not go public. Instead, the financial models are adjusted, not the costs, the revenues. Hotel projections at Trojena, the mountain ski resort, are inflated to levels that would make five-star properties in Dubai look modestly priced. Internal rate of return figures are tuned to acceptable levels. A project manager questions the assumptions. He is removed. The number keeps moving. By the time the internal audit lands on the NEOM board table in spring 2024, the projection for full completion by 2080 is $8.8 trillion. That is not a misprint. $8.8 trillion. More than 25 times Saudi Arabia's entire annual government budget. More than 8 times the value of the kingdom's sovereign wealth fund. More than the combined GDP of every country in the Middle East. The audit does not find optimistic miscalculation. It finds evidence of deliberate manipulation by certain members of management. Revenue models inflated to justify cost overruns. Assumptions structured to produce acceptable returns, not accurate projections. One email captures the culture. An executive instructed consultants that we must not proactively mention cost at all before a key presentation. The Wall Street Journal obtains the audit. The world reads what the board already knew. The project does not stop immediately. It keeps going for 18 more months. Publicly, Officials say construction continues as planned. Internally, new contracts freeze. In April 2025, the construction workforce is cut by 35%. In July, over 1,000 NEOM employees are relocated from the site to Riyadh. On September 16, 2025, the Public Investment Fund formally suspends construction on the line until further notice. No announcement, no press conference, the machines just stop. And then this week, the contractors follow. March 12th, Hyundai Engineering and Construction receives formal termination notice on the 12.5-kilometer underground tunnel, a joint venture with Samsung C&T and Greek contractor Archirodon, valued at $1.6 billion. The tunnel, using drill and blast method through variable geology, was designed to carry the high-speed transit system connecting the line to the outside world. Now it stops at partial depth, a sealed bore in the Tabuk rock. March 26th, Eversendai receives notice. The structural steel contract for Trojana Ski Village terminated. March 29th, Webuild's $4.7 billion contract ends. 3 dams, a 2.8-kilometer artificial freshwater lake, the Beau Hotel, cantilevered over a mountain valley, all 30% complete, all stopped. Combined value of the 3 terminations, over $6 billion. All classified as termination for convenience, the client's choice, not a contractor failure. The companies absorb it professionally. Webuild's backlog outside NEOM exceeds 50 billion euros. Nobody goes bankrupt. The contractors were always bigger than the project. 260 excavators operated in the Tabuk Desert. 2,000 trucks moved earth around the clock. A 170-kilometer trench is visible from space, scored across the sand in a perfectly straight line. The longest intentional excavation in desert geography ever made. 40 structural cores started, each designed to reach 500 meters. Today they stand as stumps. No steel in the upper sections, no cladding anywhere, no glass on any surface. Phase 1 is 2.4 kilometers of foundation. The full project was 170 kilometers, 1.4%, and it is not complete. To finish the line on the original timeline, the construction rate required across all 170 kilometers simultaneously would need to run at 15,000 times the normal pace of high-rise construction. Not an exaggeration from critics. That is the arithmetic of what the schedule demanded from the physical world. The physical world did not comply. The Saudi government is not done with the site. The cleared land is real. The airport functions. The road network carries loads. The Red Sea coastline is accessible. In February 2026, a $5 billion deal is signed with DataVolt for an AI data center campus in the industrial zone. Red Sea seawater for cooling. Renewable power from the grid that does exist. Operational by 2028. The trench built for a city will hold fiber optic cable. The desert that rejected 9 million people will serve GPU clusters running inference workloads for Europe and Asia. Not a civilizational revolution, a data center, a very expensive, very well-located data center. In its way, it is the most honest engineering decision the project ever made. Here is the thought that changes how you see all of it. The engineering problems were real. The water problem was real. The glass heat problem was real. The thermal expansion across 170 kilometers of continuous steel, real. The pile count, real. Engineers identified every one of them. They wrote reports, they ran the numbers. They knew precisely what the project required, but they never got to solve any of it because the line did not fail in the desert. It failed in a spreadsheet. Deliberate manipulation. Projections adjusted to tell a prince what he wanted to hear. The engineering was stopped before the engineering started. The hardest structure ever conceived was not beaten by geology, not by the desert heat, not by the limits of steel or glass or concrete. It was killed by a financial model in a boardroom in Riyadh. That is not an engineering failure. That is a different kind of collapse entirely. If you want to understand how the world's most ambitious megaprojects actually get built and how they die, subscribe. The engineering is always where the truth lives.